Have you ever wondered how a website takes a massive shopping cart and perfectly divides it up among 5 different warehouses? Or how a travel app can ask 10 different airlines for the best price, all at the exact same fraction of a second? Inside the internet, every byte of your data follows a precise path, guided by a network of incredibly clever, invisible traffic directors. Today, we open the Master Builder's Playbook to look at the real engineering that makes this possible. We call it advanced routing. We will learn the actual professional names for 3 of these critical traffic directing tools. By understanding these routing rules, you'll see exactly how massive digital systems manage millions of requests without getting confused, dropping your data, or crashing entirely. Imagine hosting a massive pizza party. You order 20 pizzas, some pepperoni, some vegan, some gluten-free. When the delivery arrives, you don't hand the entire giant stack to one person. You slice the order up, handing specific boxes to different friends so they can take them to the right rooms. Computers do the exact same thing. When you click Buy on a complicated order, your computer sends what software engineers call a composite message, essentially one giant grocery bag containing many different individual items. This diagram shows the problem with that. Look at the composite message leaving the yellow order entry box. It's full of different colored items. If it hits that question mark cloud in the middle, the system freezes up, because back-end servers need to process each of those items independently, not as one giant tangled clump. To solve this, developers use a tool you can see right here, the splitter. Notice how the green splitter box takes that mixed-up message and neatly breaks it apart. Now, item 1 and item 2 are on their own distinct paths. By splitting the message, no single server gets overwhelmed. The computer can handle all of those smaller tasks at the exact same time, keeping the entire network running smoothly. Now let's flip that specific scenario around. Imagine you are meeting a group of friends at a movie theater. Rather than buying tickets one by one as people trickle in, you wait by the door until everyone arrives, and then you buy one single group ticket. In software engineering, computers frequently face this same waiting game. After splitting tasks up, the system often needs to collect and combine all the individual results before it can move on to the final step. Take a close look at this illustration. We currently have 2 separate responses coming back from the inventory systems, but when they hit that question mark cloud in the middle, they create a mess. Messages travel at different speeds. They might arrive out of order or get delayed. The fix is shown right here in the center, an aggregator. Notice how it takes the place of that confusing question mark. It grabs those scattered replies, groups them together, and produces one clean, unified, confirmed order for the billing department. Software engineers call this aggregator a stateful filter, which is really just a fancy way of saying it has a memory. It can safely hold on to the first arriving pieces of data, waiting patiently until the entire set is completely finished. Without aggregation, the final server would be bombarded with scattered, incomplete data. This tool turns chaos into a single, actionable instruction. For our last tool, imagine walking into a crowded, open-air market looking for a specific vintage toy. You don't walk to every single stall. You stand in the middle, shout your request to the whole room, wait to hear who has it and exactly what they charge, and then you just pick the best offer. This happens constantly in software. A client computer takes a request and broadcasts it over what we call a pub-sub channel. Think of it as a giant digital loudspeaker that shouts the new request out to a large group of connected servers. This chart breaks the process down perfectly. In the top section, you can see the initial quote request moving through the pub-sub channel. It continuously broadcasts outward, asking vendors A, B, and C to independently process the request and send back their prices. Then we move to the gather phase. Looking at the bottom section, our old friend, the green aggregator box, is hard at work. It collects the varying quotes from all 3 vendors, evaluates the data, and returns a single best quote back to the user. When you put the loudspeaker broadcast together with the patient aggregator, you get a highly effective system with a very straightforward name, the scatter-gather pattern. By scattering the question and gathering the answers, a computer can poll a dozen independent systems and make an optimal decision in milliseconds, even if it doesn't know exactly who is going to reply. So we've walked through the journey. You know how to split massive jobs into manageable pieces. You know how to use an aggregator to wait patiently and combine the answers. And you know how to shout out to the network to gather the best possible results. You are now equipped with the real, professional secrets of advanced routing. But routing is just the plumbing. Our next adventure takes us to the buildings themselves, where we'll explore how software that used to be built as one giant, rigid block is being broken down into tiny, independent pieces called microservices. But for now, you have the tools. You can look past the screen and start decoding the invisible architecture that powers our digital world.